In Chapter 7, we are going to identify the differences between two groups that we are studying or trying to make a comparison between. An overview of what we're going to be looking at is that the statistics that we gather from whatever testing we're doing can give us an idea or tell us whether two conditions or groups differ from each other in one or more variables. The two conditions can be either the same group of people tested in two conditions, traditionally called Group A and Group B, or two different groups of people who perform in either condition A or condition B. So once again, we're going to be looking at whether or not what we're studying, we're looking for differences, not similarities, but differences in the groups. So the tests of significance that we talked about, I believe in Chapter 3, the parametric and non-parametric testing. Parametric, you need to know a little bit about the data, and you're probably going to estimate at least one of the parameters within the sample of statistics. Always going to have a normal distribution, and it's going to, parametric we're going to use for interval, ratio, scales of measurement. Remember, interval ratio is going to be continuous scales of measurement versus non-parametric, where you know nothing. It's usually used for nominal and ordinal level, which is categorical. So remember, we had our 4 different levels, and 2 were categorical and 2 were continuous. And the interval ratio, once again, was going to be continuous, and the nominal ordinal was going to be categorical. And remember, we talked about tests of statistical significance, the non-parametric, and one of the primary tests that you see a lot is something called the chi-square, used for nominal data, categorical, and it compares a number in a group with the actual number. The expected number can be based on theory, experimental, or comparison groups. The data must be categorized before using, so we have to make sure that we have it categorized properly. It's popular in the analysis of research data, especially survey data, and we've all completed surveys right down to evaluations that we do for our classes. We basically, when you look at that now, you're going to say, oh, that's going to be categorical data. A lot of times, like I said, it's used, chi-square is used, and what we're going to be looking at is finding relationships between survey items. A lot of times, if you're doing a survey, they'll ask you how satisfied you were with something, and then they'll follow up a little bit and kind of pick your brain and ask you different questions about whatever they're surveying, and they kind of want to, what they're going to use with that data is find that relationship between what they're studying and the variables that are out there. There's going to be something called a contingency table, and I remember telling you before that the contingency table is, made up of basically a little table, and there's so many vertical and so many horizontal, and you're going to put your variables in there, and you're able to, there's a specific calculation, although no one does that calculation anymore because we have SPSS do the calculations for us. And what chi-squared is going to do is measure the association between those variables. And continuing on, we talked about non-parametric, the parametric. The couple that are very significant are ANOVA, and the ANOVA is comparing 2 or more matched groups. Whereas the t-test, which is also known as a non-paired t-test or a student t-test, just looks at the means of 2 groups. Okay, so that's a big difference, and you should probably know that. Once again, like I keep repeating myself over and over again, it's more theory in this course than it is actually having to do anything. So if I'm going to ask you, does the ANOVA compare only 2 groups, or which of the following parametric tests of significance use 2 groups, you would know it would be ANOVA. And if it's something that is asked 2 or more groups, you're going to know it's a t-test. So once again, just kind of remember the theory and remember the when and how you would use these groups. So when you're actually reading studies, or you're reading journal articles where they've done studies, and they will say, I've used an ANOVA to compare the tests of statistical significance, you're going to have an idea whether or not that was used correctly, because that would only be used when you compare 2 or more groups, and a t-test would only be 2 groups. Another test of statistical significance that's used in parametric data is something called an analysis of variance, an ANOVA. And what you look at with an ANOVA is, once again, the difference between group means and their associated procedure. The one thing that separates this from a t-test or a student t-test is a student t-test. You're going to look at 2 groups. In ANOVA, you can look at 2 plus group means, and you're looking at the variation between the groups. The nice thing is where you are kind of limited in a t-test to 2 means. If you add more means, group means in a t-test, you're going to stand the risk of coming up with a type 1 error. If you recall, we talked about type 1 errors in the last chapter. The nice thing about an ANOVA, or using an ANOVA, is that you're gonna eliminate that error of using using a t-test with only plus, should I say, more than 2 groups. The ANOVA, like I said, you can go 2 plus, you can go 3, 4, however many group means that you're actually measuring, and you can come up with some pretty good confidence with that. So looking at t-tests as a measure of variance, when we talk about variance, we're talking about variables, things that change, things that are different. And the scores vary between 2 groups. Between groups variation is actually what that's identified as. And that's what we're kind of looking for. We're looking to see if we have similarities or differences, and the scores are going to be different between the 2 groups that we're studying. Once again, they vary within each group. There are 2 measures within participants' variation, one for treatment group and one for the control group. And I think we've all kind of read studies where we had this group that was being studied, and then we always had the group that was either given the placebo or identified as a control group. We are interested in whether or not there is some sort of a variance between those 2 groups and how significantly that variance is. The t-test is calculated. This is just a calculation. I don't want you to think you have to measure this or that you have to memorize this for an exam. You don't have to memorize it. Just understand how a t-test is calculated. It's calculated by the difference between two means and then dividing the result by a measure representing the variation in scores for that particular group. And that measure of variance is something that we call standard error of the difference. So once again, I don't want you to think that you have to memorize that. I will never have you do a calculation, let's put it that way. You might want to have an understanding as to how we do or what the statistic t-test actually does, but you won't by any means have to calculate one. Remember, this course, I'm really trying to keep it simplistic and just make sure that you have basic concepts of statistics. And an area that we would look at to measure the difference between between variables that we're measuring and kind of look at the size of the difference between the conditions is something called Cohen's d, and that's what it does. It gives basically we're looking at the amount of difference or the size of difference between the two conditions that we're studying. So even though we want to identify in some of our other statistical testing, we want to see if there is a difference. This is going to measure how much, or the size, the amount. The mean difference, the actual difference that's being measured, is converted into something called a z-score. And the z-score is how you would present that final data. Not the mean, but the z-score. Effect sizes from different studies can be evaluated even if the variable has been scored using a different metric, meaning that it can be converted, that number can be converted, even if it has been measured using some different type of measurement, it can still be converted back over into a z-score, or the mean difference. So what makes this nice is that if we're looking at studies that have come from other countries, and we know that they use measurement as in metric system. In the States, the United States are the only states that do not, that we're able to convert that. So Cohen's d, once again, is something that measures the effect size used to indicate the standardized difference between two means. So what we're looking at is the difference between two means that is kind of common or standard. It can be used to accompany reporting of t-tests, ANOVAs. It's also used in something called a meta-analysis. A meta-analysis is something that's used for the comparison of two independent studies. Oftentimes a meta-analysis is used whenever you see a study that's a clinical trial or a healthcare study, and we're trying to identify the difference between group 1 and group 2, or group A, group B. Usually you will see a meta-analysis used. It's very useful. Like I said, in health sciences you see that quite often. Cohen's d is an appropriate effect size for the comparison between two means. So that's a definition that I want you to kind of put in your head. If you're going to use Cohen's d, it's going to be the size, the effect size for the comparison of two means. So non-parametric testing transforms what scores we've gathered from whatever tests we have run. It puts it into ranked data. And if you recall, going back a couple chapters before, ranked data is going to be our nominal and our ordinal data. So remember, we can start to rank things, and then remember our parametric data is going to be data that is continuous, not categorical. The tests that we can use for non-parametric testing, they're resistant to outliers. We talked about outliers earlier. Outliers are going to be those random scores that are out there that just kind of show up, and we know that something isn't right with that score. We have all our scores pretty much distributed normally in a normal distribution, but then we have this outlier, and it sometimes can throw off what our scores, what our actual determination is of our study because of an outlier. So a lot of times we don't even look at those outliers. We just leave them there, and we look at the scores that are closest around the mean. Non-parametric tests are also resistant to skewness. We talked about skewness as well. And non-parametric testing, like I said, you're going to see it more in data that is we want to rank, something that we want to rank, higher, lower. If we want to maybe rank someone's job satisfaction from, great, very good, good. Okay, that's a non-parametric testing. The same thing like when you do an evaluation for a course, you get that, strongly agree, don't agree. That's ranking data.